This video is about the algorithm and how to fill the table using dynamic approach for the matrix chain multiplication algorithm. So for example, we have taken here four matrices A1, A2, A3, A4 which are compatible for multiplying, having sizes A1 10 cross 20, A2 20 cross 50, A3 50 cross 1, A4 1 cross 100. So we have to find the resultant matrix using MCM, and in which order we will multiply we will see that using MCM. So since we have four matrices here, we have taken a 4 cross 4 table, 4 rows and 4 columns, in which we have seen if I is less than j, this side is I, this side is j. If I is less than j, then we will fill. If I is greater than j, then it is not possible, or the matrices are not compatible with each other for multiplying. And for I equals to j, that is the diagonal, when we have only one element, it will be 0. More information can be drawn from the previous video. So here we will find out the values for I is less than j. So we will fill diagonally, that is in this way. If this diagonal is complete, then the next diagonal this, then the next diagonal this. So for this diagonal, that is this box 1 2 m 1 comma 2 ij 1 2. So minimum k value will be from I is less than equal k is less than j. So here k has the only value 1, and using the previous formula, that is this formula, mi comma k plus 1 comma j, r means size, I minus 1, k and j. Using this formula we will calculate the value of this. It comes as m of 1 comma 1 2 comma 2 r naught r1 r naught into r1 into r2. So which evaluates, these are 0, which evaluates as 10,000. Similarly for 2 comma 3, where k has the only value 2, it comes to be 1000. For 3 comma 4, it is 5000 for the value of k as 3. Okay, this is completed. After doing this, and then this grid was 2 comma 3, this diagonal grid, that is 2 comma 3 comma 4, this is also completed. This diagonal is completed. Then next diagonals, this next diagonal is this one, that is this grid 1 comma 3. For m1 comma 3 we have two values of k equal to 1 and k equal to 2, but we have to take that value of k for which my sum will come as the minimum. So I have written according to the formula, and then values come as 1200 and 10,500. This is minimum, so k equals to 1. We are storing the k values in another table named as S, which is required for finding out the parenthesis order in which we have to multiply the matrix chain. Similarly for 2 comma 4, this diagonal, this thing is 2 comma 4. So for 2 comma 4, it is 3000 for the value of k equal to 3, and for k equal to 3 again 1 comma 4. This diagonal is completed. Then this diagonal, only one element, that is 1 comma 4. So it comes as 2200, and we have stored the elements in the table S. For what value of k we get the respective value in the M table. It is stored in table S. These have no value because we don't get any k, and for this we have stored the value of k. Then procedure MCM. This is the main algorithm from here to here, and it takes input, as earlier I had said, from these sizes r0 r1 r2 r4 like up to rn. So n is my number of matrices, length of r, this is r, this whole can be considered as an array named r, length of r minus 1. We have here 1 2 3 4 5 numbers, but the size is 4. So n equal to number of matrices we have found out. Then for I equals to 1 to n, first what we do in the table, we have done these as zeros. We don't have to fill about this, so we will not consider them, but we have to fill these as zeros because these are required. So here we have done it. Mi comma I equals to 0. It will make all the diagonal elements as 0, and then we will start filling out these values. Okay, while filling out these values, let's note, we have to notice that m1 comma 2 for the first diagonal, for these three elements, these three, the difference between I and j is 1 1 2 2 minus 1 1 3 minus 2 1 4 minus 3 1. For the second diagonal it is 2 1 comma 3 2 comma 4, and then for the third diagonal it is, the difference is 3 1 comma 4. So for diagonal equal to 1, difference will be 1, diagonal equal to 2, difference will be 2, for diagonal equal to 3, difference will be 3. So here we are doing that thing for I equal to 1 to n minus 1. Why n minus 1? Because 1 2 3 4 corresponds to the number of number of matrices, that is 4 matrices, but this one is 0, so remove that. So we have left with n minus 1, 4 minus 1 column, first column. If here 5 6 7 8 is there, then this one will still be 0, and then we will have 7 things to fill, that is 7 diagonals to fill. Therefore for I equal to 1 to n minus 1, here also we can see I equal to 1 2 3 and not 4, n minus 1. Then for d equals to 1 to n minus I, the difference is from 1 to n minus I. When I equals to 1, the difference when I equals to 1, the difference is 1 2 3. When I is equal to 2, the difference is only 2. When I equal to 3, difference is only 1. So each time it is reducing, so it is n minus I. And then j, we have got I, that is this thing we have got, and this is j. How can we get j if we have d? D plus I is j, because d was the difference of j minus I. Taking this side, j equals to d plus I, and then m of d comma j. So now this is my d and j. D comma j is whatever I had got the formula earlier. This formula we have written here. Here I is equivalent to d because it is substituting these values, and then j is the same. For k, when we do in programming, for k we have to take loop. I have not written here, but we have to take a loop, and then for which minimum value of k we get the value in m, that we have to store in the table s. For that we have to write the code and then return. The for loop is finished, and then outside of all the for loops return m of 1 comma n. By returning m of 1 comma n, what we are doing here, 1 comma 4, that is we are returning this value. So it is the minimum number of scalar multiplications required for multiplying a from a1 to a4. So it is this value we are returning. Then we have the procedure MCM order, that is in which parenthesis order we will get the minimum number of scalar multiplications, that it is if I equals to j, if one element is there then ai, else it is a recursive function, it is called, which is using the table S. Here it is this is the code, we have to use the table S at worst time complexity for this procedure. This procedure is O of n square, because maybe the whole table will be used, so it is n cross n, so it is n square, and here it is, this is O of n because it is using k, then this whole will be n square because another for loop, and this is another for loop, therefore O n cube. This is O of n, this is constant time step, so the whole procedure is taking order of n cube. So here in this example from A1 to A4 we will find out the parenthesis ordering. So first it is S of from 1 to 4, I is 1, j is 4, S 1 4, this is here, then S of I is here 1, I comma j, S of I comma j, here we will see S of I comma j is 3, so here 3, then S of I comma j plus 1 means 3 plus 1 is 4, j is 4, 4 comma 4, so, and then the closing parenthesis here, then S 4 comma 4, this condition is satisfied, I is equal to j, 4 equal to 4, therefore ai or a4 will be printed. And then for this the brackets S of I, that is 1, I comma j 1 comma 3, 1 comma 3, that is 1, we have written here 1, and then 1 comma 1 plus 1 is 2, and then j value 3. This one will print a1 because 1 equal to 1, then this will print the brackets, and then the remaining these two steps, it is 2 comma I, that is 2, and then 2 comma 3, 2 comma 3 is 2, therefore this is 2, and then this is 2 plus 1 3, and then j is 3, 3 comma 3 will print a3, and 2 comma 2 will print a2, following this thing. Therefore we get the order, we have to parse this tree, so it is taking from left to right, a1, a2, a3, a4, so it is these two, then this, and then the whole thing. If we will do, then we will get the answer in 2200 number of scalar multiplication steps. So this is all about the matrix chain multiplication.